Who is going to present today?
So group C.
Yeah, let me check. Yeah, so first is reference variables versus pointers.
Hello, sir. Can you hear me?
Yes.
Okay. So, sir, first of all, let me verify every member of our group is here or not.
Okay.
Sohan is here. Rajinish is also here, right? Sumana is here. Rahul and more. Yeah, sir, everyone is here. So, shall we start, sir?
Yeah, please.
Sir, can you see the screen now?
Yes.
Okay, Sohan, you can start.
Yeah. So good morning, everyone. I am Sohan, and the topic given to us is reference variables versus pointers. We'll be also covering pass by value versus pass by reference,
Okay.
and we'll have a comparison between C++ and Java, how these things are done.
Okay.
So we are a team of six. The team consists of Sumana, Rajneesh, Hashir, me, Anmol Paliwal, and Rahul VU. So we'll be starting now. So I'll be explaining what exactly is a reference, what exactly is a reference variable. So reference variable is just like giving a name, a new name to an existing variable so that we can use it as we want. So for example, some realistic example I'll think. So if I give Yuvraj a name Baba, so whenever I say Baba, we all will know it will be referred to Yuvraj. So in that case, it applications include like whatever we want to do throughout the function. It directly affects the actual variable name. So it will be better if I explain this through an example, which is in the next slide. So I'll be explaining this example. So it's a really very simple C++ program. So in this main function, when we execute it, a integer x is defined here, and its value is initialized to 10. So I declare a new reference variable named ref, and we give it the address of x. So now actually the reference variable and x will have the exact same address in memory. They both refer to the same address now. So if I change the value of ref to 20, we can see x. We have outputted the value of x. We have printed it out. The value of x. We see it is 20. So changing the ref also changes the value of x. That is what we see from here. And if we modify the value of x, we can see that the value of ref also gets changed here. So in the second second printout statement, we are seeing the value of ref is also changed to 39. So that is it. I want Anmol Paliwal to continue from here.
Hello everyone. I will be giving a brief explanation about pointers. Basically, a pointer is a variable that is used to store the address of some other variable. Now, the process of obtaining the value at the memory address stored in the pointer, it is done usually with the help of a dereferencing operator, which is asterisk in case of C++. Using pointers significantly improves the performance for repetitive tasks like traversing iterable data structures, for example, string or vectors. Content and actual format of a pointer depends on the underlying computer architecture. Copying and dereferencing pointer is much cheaper in space and time complexity than to copy and access the data to which the pointer points. Now, the concept of pointer will be more clear with the help of C++ program in the next slide. So in this program, in line number 4, we are initializing and declaring a variable a with the value of 20. In next line, we are declaring a pointer called IP. In sixth line, we are storing the address of A in the IP using an ampersand operator on A. Now we can see that when we print out the value of A, it prints out to be 20. In line number 11, we are basically printing out the content of IP, which is address of A, and it is output in hexadecimal form. Now, in line number 14, we can see the usage of dereferencing operator. It is an asterisk symbol before IP, and it basically print out the content of the memory location in IP. So 20 is printed out here. So with this, we now move to the next slide.
Okay. So these pointers and reference provide same capabilities in many situations, but there are some differences too. Okay, so now let's have a look at some of the main differences. First of all, this initialization. So in case of pointers, both the declaration and initialization can be in the same statement or in different statements or lines. But in the case of reference variables, both initialization and declaration should be in one statement. And this actually depends on the compiler also. But so now this example we have shown here is with respect to the turbo compiler. Okay, so in the example here, first this left side is showing this pointers case and the right side is showing reference variables case. So first we declared integer x is equal to 12. Then we are declaring the pointer variable pointer p. Now in the next line we are initializing that pointer. So this is perfectly valid both in the separate statements. But in if you move to the right side, there we are declaring the reference variable in one line and initializing in the next line. This is not valid in the case of reference variables. So in the case of pointers, initiation and declaration can be done in the same line itself. This is perfectly valid. And so we only have in the case of reference pointers, we only have the option to both declare and initialize in the same statement itself. So moving on to the next point is that pointers can offer multiple levels of indirection. That is, a pointer can point to another pointer, which further points to another pointer, and goes on like that. But in the case of reference, only one level of indirection is allowed. It only refers to a normal variable directly. So let's look at this example. So here we are declaring an integer variable a. Okay, so there is typo here, so it is semicolon. Okay, and now we are declaring and initializing a pointer p, which is pointing to the address of variable a. This is perfectly valid. And okay, so here is also small I. Okay, now we are declaring another pointer and initializing with the address of the previous pointer p. So here the q is pointing to another pointer p. So there is some dual level of indirection happening there. So this is perfectly valid in the case of pointers. So coming to the case of reference variables, first we are declaring variable b, integer variable b. Now we are referring reference variable p to that. Okay, so here it is b actually, to that particular variable b. Now what we are doing in the next statement is that we are declaring another reference variable which is of dual level indirection, which is actually referring to the previous reference variable. So there is like a dual level indirection happening here, which is not valid in the case of reference variables.
What if I'd say int and q equal to p?
Int and q is equal to p. So that will be discussed in the next point.
Okay.
So yeah, so pointers can be, so sir, it is actually like 1 minute. Sir, if in the case of int and q is equal to p, it is only like a one level indirection, right? But it is it is valid, sir.
Yeah, it is valid.
So in the case of a pointer reassignment, yeah, okay, let's come to the pointer reassignment. In the case of pointers, once we assign an address to this pointer, it can be reassigned. But in the case of references, reassignment is not possible. So let's have a look at this example. there is like two integer variables a and b, which are initialized with their corresponding values. So we are declaring a pointer p, and which is pointing to the address of variable a. Now we are reassigning that address with the address of b. So this is perfectly valid in the case of pointers. This reassignment is valid. But in the case of, coming to the case of reference variables, we are declaring x and y and initializing it at first. Now what we are doing is we are referencing p to a. Next line we are reassigning that reference, like we are referencing that again to b. So here in this case it is invalid, and it will throw an error like multiple declaration is not allowed. So this reassignment in the case of pointers is actually makes it useful for implementing data structures like tree linked list, where we use this pointer for this traversing nodes. So where this reassignment is needed. So next point is that pointer can be assigned as null. That means a null pointer is allowed, but a null reference is not. Okay, and pointer can also be declared as void, but reference can never be void. So here it is shown. This void declaration is valid in the case of pointer, but void declaration is not valid in the case of reference variables. So coming to the next point, this is one of the major important difference. And pointer has its own memory address and a size on the stack. But in the case of reference, it shares the memory address, but also takes up some space in the stack. It shares this because it is referring to the same variable, right? It is like more like an alias. That's why it shares the memory address with the memory with the variable it is referring to. Okay, that's all with the main differences. Let's move on to the function parameters, which will be explained by Rajneesh.
So these function parameters, these can be called in three ways: pass by value, pass by reference, and pass by pointers.
Yeah, 1 second. 1 second. So why do you need reference variables? Are you talking about that in? I mean, it's like whatever you can achieve with reference variables, you can already do it with pointers. Yeah, in C++.
Yes, sir.
So why do you need reference variable at all? Are you talking about that?
Sir, in the I showed some differences, right?
Yeah.
Yeah, and the pass by reference and all these things will be discussed further.
Okay. All right. Go a little slow.
Okay, sir. Thank you.
So there are four terminologies here which we need to understand to get deep inside this pass by reference and value. So suppose there is an example void swap int x comma int y, which is declared above outside the main. Then we have int main, and then inside that main we are calling swap a comma b. So the four terminologies here are that int main is calling swap. So int main, that main is the caller function. This swap function is being called, so it is called callee function. The parameters in this void swap int x comma int y, these int x comma int y, these are called the formal parameters, whereas in the main function swap a comma b, where we pass these values a comma b, these are called the actual parameters. So next slide.
Hello everyone, I'll be taking you through pass by value. Pass by value means that a copy of the actual parameter value is made in the memory. So the caller, the function that calls, and callee, the one that is being called, have two independent variables with the same value but at different location. In pass by value, values of actual parameters will be copied to formal parameters, and these two different parameters store values in different locations. We usually use pass by value when we are only using the parameters to make computations and do not need to make changes in parameters. It will be more clear when I explain it with the example. Next slide. This is a C++ code which is a simple swap function. In this, there are two variables x and y. X has the value of 3 and y has the value of 4. Now, in line 11, what are we exactly doing in the calling procedure is we are passing the values of x and y to the function definition, which is to line 17. The values 3 and 4 get passed to variables x and y, which are a different pair of x and y and are at a different location. These variables x and y are local to this function. So all changes made in x and y are made in this new location and are confined only to this function. When this function procedure finishes, we get back to the calling procedure. Then the variables x and y will get destroyed. And whatever changes we made in the variables will not get reflected back to these x and y in the main. As we can observe here in the right side, when we print x and y in the swap function, we can observe that the values are swapped. But after the swap function, we can observe that the values are not being swapped because the changes we made are in the x and y in the function, and they are not reflecting in the main. And Anmol will take you through what is pass by pointers.
Hello. Pass by pointer
Yeah,
means to
one second. So
Yes, sir.
can you go back to the previous slide? So can somebody explain? It is to everybody, yeah, this question. Can somebody explain what happens when you what happens when you compile this code? I mean, how compiler implements this? You know this, like how is it done using a stack? Calling a function, how is it done using a stack?
Yes, sir. It allocates a different stack pointer for the calling function and the calling function, right?
No, there is one stack segment. So what in line number 11, when compiler encounters this, it will
Yeah.
insert code for putting copying x and y to the stack on top of the stack.
Yes, sir.
Okay.
Sir.
And the pointer, the program counter, which is the pointer to the next instruction to be executed, that will be passed to the line number 17. And then line number 17 will execute from there on. It will just look at the stack, whatever values have been copied to the stack.
Okay,
And
sir, but,
you will learn this thing when you learn about how compilation works in the next semester.
sir, I have a doubt. In this
Yeah.
case of there are two functions, right? Main and swap pass by value. So
Yeah.
these two things actually have different stack frames, right?
No. There is only one stack frame. Okay. For
Okay.
one thread of the program, there is only one stack. So you have one stack. You have a stack frame for the main function, and on top of that, you have a stack frame for swap by value.
Yes,
But
sir. I was mentioning that only. On
yeah,
top
it
of
is in the
yeah.
same segment of the memory. It's called the stack segment.
Yes, sir.
Below you will have a stack frame for main, and then
above that.
in preparation to the call at line number 11, a new stack frame will be added, and the values of x and y will be copied to that stack frame, and
Yes,
then
sir.
the value will the program counter will start pointing to the line number 70, and then in that stack frame x and y are copied. So that's what we mean by pass by value.
Yes, sir.
Okay.
Okay.
So all these local variables of a function are in the stack.
Stack.
Yeah.
Can we continue, sir?
Yeah, continue. You're going a little faster because I missed some lines you didn't read in the slide. Okay.
Okay.
Okay. Pass by pointer means to pass a pointer argument in the calling function to the corresponding parameters of the called function. The called function can then modify the value of variable to which the pointer argument points. This will be more clear with the C++ program in the next slide. So in this C++ program, we are trying to swap the values of two different variables. In line number 18, we are sending the addresses of variable x and y to the function swap pass by pointer in the line number 2. So int star x basically stores the address of variable x, and int star y, y pointer basically stores the address of variable y. Now we can change the content of these variables using dereferencing operator. So in this code, we can, from line number 4 to 7, we can see that we have swapped those values. And when we print out, after this function is executed, we print out the value of x and y, and we can verify that these values are swapped, unlike the function pass by value. So with this, we now move to the next slide.
There is no, I mean, what is the difference between pass by pointer and pass by value? Is pass by pointer also pass by value?
Sir, basically, when we pass by pointer, the address of X is copied into address into X, and address of Y is copied into Y. So we are now dereferencing
Yeah,
these addresses
you are
to.
using the same variable for X and Y. That's why you have to, you are using. So what happens is that in pass by value, you just copy the values. Okay.
Yes, sir.
Just so
And
happens that
hmm,
earlier you used to call the contents of an address, contents of a memory location or a register. Uh, but in this pass by pointer, whatever you call pass by pointer, instead of copying the contents, you are copying the address.
copying the addresses. Yes,
Yeah.
sir.
So it is
So
actually
and
also. So
also changing the variables in the main. So actually 3 and 4, X and Y of the main are not actually getting tampered in case of pass by value. Whereas in pass by pointers, we are actually changing the contents of X and Y variables. Hello, sir.
yeah, that is true. But my larger point is that uh, there is, I mean, in terms of the operations, if you just think about uh, what is happening internally, what happens to the stack while this program executes, it is still writing something onto the stack. Okay, instead of
Yes, sir.
content,
Yes,
it
sir.
is writing address. So
Yes,
basically,
sir.
Yes, sir.
Hmm.
Yes, sir.
basically pass by pointer is actually nothing but passing the address of passing by value that.
Address.
Yes, sir. X and Y are local variables of function swap pass by pointer. So the address of X and Y is copied into the X and Y of this function.
Yeah. I mean, I don't know where you go. I don't really like this terminology of pass by pointer because in most programming languages do not have this mechanism of pointers. Most programming
Hmm.
languages do not allow you to get the address of a memory location. Okay, because
Yes,
that's
sir.
extremely risky thing. And that is the reason why when you do your data structures and algorithms course in the third semester, you invariably run into segmentation fault. Segmentation fault happens when you when a memory location whom you don't have address is dereferenced. That is what is segmentation fault. Yeah, when you write or read from a memory in which the program has no permission to access. Now, that since that is extremely risky, most programming languages do not allow that, except in those languages which allow for system programming like C, C++, Rust, and all these languages. They do not allow, and that is one reason why C++ invented or more high-level languages like C++, Java, etc. To overcome this difficulty of pointers is what they have introduced the reference variables. Okay, it is less risky.
Yes, sir. That is what was the answer for your question which you had asked. So I was going to clear it now.
Is it coming in the later slides?
No, sir. I was going to explain it. Yeah, you had asked in the previous slide to Hashir.
Yeah.
So I was going to
So
explain
the
it.
reason, yeah, so it's extremely risky to pass pointers, and passing pointers is nothing but instead of writing the contents, you just pass the argument, pass the address of a memory location as value. Okay, but since it is risky, most programming languages do not allow that. But now you need a way to pass information. Yeah, you pass because if you just have only pass by value, then life will be very complicated. Because if you want to do a linked list or something like that, you all know that you need some other mechanism because you want to change the contents of a memory location. Yeah, that's a very important thing. You want to point to some memory location and say change the contents of this memory location. Now such a thing is not there in if you don't have a mechanism other than pass by value, that is impossible to do. And that is why Java, for instance, they don't have they allow for reference variables.
Java doesn't have pointers, so
Yeah,
whatever you had
exactly.
explained.
Yeah, yeah, I think that is coming. Yeah.
Yes, sir.
Yes, yes, sir.
All right, all right. Okay, then go on.
Um, So in the next slide, we'll be discussing pass by reference. So pass by reference means actually just passing the address as the argument. We are passing an argument by reference here. So what actually it
Yeah. So
does is,
here, 1 second. Here is another problem. When you see, like I said, passing the address is passing by value. Okay. Instead of putting the value, you pass the address. That's all the difference is. Both cases you are passing a integer. Okay. In one case it is the contents of a memory location. In the other case it is the address, real address of the
address.
memory location. Okay. So
Yes.
both are passed by value in that sense. But passing by reference is something else. Passing by reference is not passing just the address. Okay. Passing by reference is actually passing the reference to a variable. Okay.
Yes, yes.
Continue.
So the callee gives a direct reference to the element calling it, the caller function. It directly gives the reference to that, and the memory address of the stored data is passed here. So whatever the value we are changing in the function, so now, so I'll explain this last point in the next slide. So can you just change the slide? So we have two functions, int main and
Can you go back?
void.
I can read the full slide.
Okay.
Municipal.
So the last point was just
Yeah,
the
1 second,
changes
1
will
second.
have.
Give me 1 minute. The column body is the same variable for the parameter. Parameter variable, the effect is visible in the follows variable. Passes an argument by reference. Callee gives direct reference to a programming element in the calling call. The memory address of the stored data is passed. Changes to the value have an effect on the original data. Okay, so one question: does C has pass by reference? C language
Yes,
pass
C
by.
language exactly. I don't know, but C++ does have it, sir.
Yeah, but what about C? Anybody?
Sir, I guess it has
No,
this pass by reference.
I
Yeah.
don't.
Why do you? Who says no?
Right, Rajnish.
Yeah. So, yeah. Why do you think that C doesn't have pass by reference?
Sir, because this pass by reference does not give us some extra power. It can be done in a different way. It just
No,
that's
sir.
as for example in Java we don't have this pass by reference, but we
We
can
don't have
No,
pointers. We
pass
actually
by
have
point.
something similar to pass by reference in Java.
similar to pass by reference, but not the exactly pass by reference which we do this in C++.
So what happens is that C language, in the strict sense of the term, C language has only one parameter passing mechanism, that is passed by value. Okay. I think here you are confusing between two things. What is passing by reference and pointers? Passing pointers is not passed by reference. That is not what we mean by passed by reference. Okay. I mean, it is true that pointers are a mechanism to address a memory location. 1 second. 1 second. You guys continue. I'll just join back. Okay. Go slow.
Okay, sir. Sohan, you can continue.
Hashir, can we move to the next slide?
Okay.
This is a really simple code, and I'll be explaining pass by reference here. We have two functions here: swap pass by reference, which takes in two reference variables as an argument, and this is the first three lines of pass by reference are just normal swapping, which we all know. And so when I'll start now. In the main function, we have declared two variables x and y. X is given the value of 3 and y is given a value of 4 when initialized. So before the swap function, we'll just print out here x and y. The values x and y have the same values 3 and 4 here. And we call the swap pass by reference function here in the line 11. So in the swap function, we are changing the values of x and y, and we interchange it, and we get the value of 4 to the x and 3, or the value of 3 to y. So, and after the swap function, we again check whatever is happening. So we see that actual values of x and y of the main function are getting changed by this swap by reference function. So it actually has an effect out of its actual scope here, because the variables passed here are reference variables. They have an actual, what we can say, some kind of connection to the real variables here, X and Y. So we move to next slide. I want Rahul to explain it.
Yeah, here we are looking at pass by value in Java. Like in Java, respective of the type of variable, the arguments are always passed by value. Like you can see this primitive type integer x and a method change. What happens is uh, a copy of the integer x is made in the stack memory and it is passed into the method change. So whatever like functionalities that uh, method have, it does on that copy only. So after returning the method or the function, the actual value of x is not changed. So like any modification inside the method is affecting only the copies. So I'll be passing to Rajneesh for pass by value reference.
Pass by value reference. So let me make it very clear that we don't have anything like pass by reference as it is like in C++. We have something different here. All the primitives like int, char, etc. They are just passed by value, whereas the objects, what happens to them is that their copy is created and the changes are made to that copy, but because the objects are passed by reference, so the changes are made to the original copy as well. So let me give it to an example.
Rajneesh, actually this whatever Java implements is the true pass by reference. Okay, so I got interrupted because of the call. I think I need to speak about this pass by value, pass by reference in a little more detail. Okay, listen carefully. So I have a caller function, I have a callee function. Now, don't think about C, C++, Java and all these things. Okay, just think about two functions. One function is going to call another function. Now, if this function is just going to look at the snapshot before passing information to the callee function is the one which is being called. Okay. Before passing the information, so it has to pass the information of the parameters to the callee function. Now, what it does is that it takes a snapshot of the values of the present function of the caller function, the parameters, and give it to the callee function. Okay, and then the callee function does whatever, and then at the end it computes a value, it returns that value. This is what is called pass by value. Okay, so whatever the callee function does on its arguments has no reference to whatever happens in the caller function. Okay, that is what is called pure pass by value. That means only the value is passed and no changes of the callee function gets affected in the caller function. Okay, I hope it is clear what is pass by value. You pass only the value, whatever changes happen in that arguments does not get reflected here. Okay, so for instance, if you look at Python, if you send a integer argument to a Python function, Python doesn't have anything of the sort reference variable or pointers or anything of that sort. Yeah, if you have an integer value, you send the value and then it's you have a function which calls a callee function and you say some f of x is there and x is changed, it doesn't get reflected back. That is pure pass by value. Okay. Now on the other hand, I have some parameters x and y. I give it to my callee function. There it is captured in p and q. Now if something happens in p, if some p is changed, then if x gets changed, that is passed by reference. Because now not only that I'm passing the value, I'm actually passing the object itself. Okay. Is it clear to everybody?
Yes, sir.
That is what is passed by reference. Now, if you look at C programming language does not have anything called pass by reference. It is true that you can somehow implement a sort of effect in the sense of pass by reference via the use of pointers. Okay, because you can pass the memory address, and that memory address can be manipulated and it can be dereferenced and changed. Therefore, you have the effect of passing by reference, but C programming language has only passed by value. Okay, and similarly, if you come to Java, Java has two real parameter passing mechanism. One is passed by value and one is passed by reference. Python also has two, pass by value and pass by reference. For instance, in Python, if you transfer a string to another to a function, and if that string gets changed, it gets affected in the the original variable. I hope those who are familiar with Python would know this thing, that strings are passed by reference. All right, continue. Hello.
Rajneesh?
Yes, sir.
Yeah.
Yeah.
So I don't think it's a good idea to call pass by value, pass by pointer, pass by reference, pass by value, reference, etc. I don't know. Maybe people might use different terminology, but in effect, there are only two kinds of parameter passing mechanism. In the strictest sense of the term, there are only two kinds of parameter passing mechanism. One is pass by value, in which you make one way to think about them is that you make a copy of the object, send it copy of the argument, send it to the callee function. The argument gets, whatever happens to the argument, it doesn't come back. It doesn't reflect in the original copy. Okay, that is passed by value. The other, where you actually pass the argument itself, and whatever happens to it gets reflected back in the caller function. That is passed by reference. Okay, continue.
Yes. So these primitives, we saw about them, and the objects, the main objects, or they are passed by reference here. So I'll tell you through an example. Ashir, next slide. So here what is happening is that we have a class named test, and inside that we have a variable x and constructor to that. Inside main, I'm declaring on object t for that class and calling the constructor function, and giving the value of x to be 5. Then I'm calling this change t. So what happens in change t, that it just changes the value of this x. It just changes the value of x in that original object as well. That is passed by reference here. So whenever we will do this system.out.println t.x, it will just print 10.
Okay, so objects are passed by reference.
Yeah, objects are passed by reference.
Yeah, but apart from that, you can actually capture functions can have reference variables as its arguments. Have you looked at that? Your earlier swap function, how do you write the swap function in Java?
Sir, that is through return process. We just return the value and just change it like that.
No. You had a C. I think I saw the swap function somewhere. Was it for C++?
Yeah, sir, that was for C++.
Yeah. How do you write a swap function in Java? That's my question.
Okay. Sir, I can. Sir, what we do here is that we just return these values instead of this reference for these primitive data types. What we do is we just return these values and store it there. So by this way we can write it.
No. But if you want to swap two variables, I mean, you have the C++ code for swap, where you pass the memory address of two locations, get it into pointers, and dereference them and swap them. Yeah, that is a swap function C++. I want to write a similar function for Java. How do I do that? Is it possible in the first place? Should be possible, yeah, because whatever you can code in.
Sir, I can do it through this class only.
No, because these are two integer variables, so there is no class involved. Anybody and anybody know how this is done? And it's a very popular trick in Java. They use it all the time. Hello.
Sir.
Okay, find it out. So basically what you do is that instead of you pass the two arguments x and y, but you capture them in two reference variables. Okay. So look it up, but let's continue with the presentation. Is it over?
Yes, sir.
Okay.
So that's it with our presentation. Thanks for everyone for giving your time. And I hope everything is clear by now. Okay, sir.
Yeah. So can you find out how to swap to how to write a swap function in Java? Using reference variables. So look it up for the next class. Okay. Let's go. Who is next?
Yes, sir. It is operator overloading.
Operator?
Operator overloading.
Yeah.
Okay. Okay, so is the screen visible?
Yeah.
Devansh, you can start.
Is the train the operator?
Yes, sir. So okay, may we start?
Yeah.
Yeah. Welcome everyone. Good morning to everyone here. I myself, Devansh Chatri, along with my team members, Manan Jain, Dish Sawant, Pratiksha, and Vipul Chandan, will be presenting to you the topic of operator overloading in C++, and we will be comparing it with Python. Let's start with the introduction. As you can see in the picture nearby, this train is totally overloaded. This is fatal, but operator overloading is not. Let's move on to the introduction.
So we'll start with polymorphism. It is an object-oriented programming concept that refers to the ability of a variable, function, or object to take on multiple forms. Operator overloading is a specific case of polymorphism where different operators have different implementations depending on their arguments. An example of this is an example of ad hoc polymorphism. Operator overloading is generally defined by a programming language, a programmer, or both. Moving on to the next slide.
Yeah, hello everyone. I'm Nidish. So I'll be explaining you operator overloading in C++ versus Python. So in the case of C++, we can redefine or overload most of the built-in operators. Thus, a programmer can use operators with user-defined types as well. Overloaded operators are functions with special names. So in C++, the keyword operator followed by the symbol for the operator which you want to overload is defined. So like any other function, an overloaded operator has a return type and a parameter list. In the case of Python, to perform the operator overloading, it provides some special functions or so-called magic functions that is automatically invoked when it is associated with that particular operator. So for example, when we use the plus operator, the method underscore underscore add underscore underscore is automatically invoked in which the operation for the plus operator is defined. So now we will move on to the next slide.
Yeah, hello everyone.
You have some code. You have some code.
Sir, we will get into the next slide.
All right.
So let's get into default behavior. By default, in a language, plus is generally used just to add two primitive data types. Like we can add two int values, two float values. On overloading, we can customize it to behave differently and add objects. Like if two objects contain strings, so on plus operator overloading, we can even add these two strings in C++. Similarly, other operators such as unary, relation, and assignment operators can be overloaded and used for our own classes. While in Python, plus can also be used to add non-primitive data types such as concatenating strings. Like if there is string Vipul and one more string Chendu, if we just add those two strings, we will get Vipul Chendu, like that. Python uses special functions for this. So let's get into the next slide.
Hello everyone, my name is Pratiksha and I am going to talk about overloadable and over non-overloadable operators. As Nadish said that we can overload most of the operators that are available. So these are the listed operators which are overloadable. Let's talk about unary operator. Unary operator operates on a single operand and binary operator performs the binary operation. Relation operators used to compare two objects of a class. Input and output operators are also called stream insertion and stream extraction operator that can be overloaded to perform the input output for the user defined types like an object. Fifth is assignment operator. Assignment operator is used to create an object just like the copy constructor. Sixth is subscripting operator overloading. This can be normally used to access the array elements, and these are the listed below operators which cannot be overloaded. First is scope resolution operator. Scope resolution operator cannot perform the expression evaluation. Both the operands in this operator are known to the compiler and they perform the scope resolution rather than expression evaluation. Second is conditional operator. Conditional operator, for this we have no fundamental reason to disallow or overloading this operator, but it hasn't seen that there is a need to introduce special case of overloading a ternary operator. Third is member selection with pointer to member. In this operator overloading, if we overload this operator, this can leads to a question whether the question is whether the operation is meant for operator overloading or it is referred by the member with pointer to it. Fourth is member selection operator. This is also the same operator overloading. Overloading this operator can lead us to the question whether this operation are made for the object overloading or an object referred by this member selection operator. Let's move to the next slide.
Okay, so now here we come up with our examples. Before that, we will have to define our classes. We will be referencing it throughout our upcoming slides. On the left side, we have the definition for the class point in C++. And on the right side, we have the definition for the class point in Python. Let's go through the point class for C++. We defined here two int variables, x and y. And we have defined another array as x points, which consists of 3, 4, 7, and 2. Now, onto the member functions. We have as public our constructor. It is a point constructor, and we have passed it x and y variables. And we will be assigning it the values that are given to x and y to the member variables here. Now, in some cases, we will also have to display what are the conditions or what are the status of the variables here. So for that, we have defined a display function, which will give out the values of the member variables x and y. Now, these next are the prototypes of the functions that are overloaded and will be referred in the upcoming slides. We have, first of all, the operator plus that is overloaded, and it will be returning a pointer object, and then we have the negate, which is also returning a pointer object. Then we have also overloaded the less than operator, which will be giving us true or false. And then we have the not equal to operator. It will be also telling us true or false. Then we have the overloading for the input stream or output stream operator. And we have defined it as a friend function. And it will return an OStream object. And next we have the plus equals to operator. And next we have the less than, which is the left shift operator. It will take the number of bits that will be used to shift the bits. And then we have the last is the subscripting operator, which will be taking the index. And now going on to the class point of the Python, we have defined a constructor here, and we have taken here x equals 0, y equals 0 as the arguments, just the same as C++, and assigning it to the member variables of x and y. Similarly, we have also defined an array x points here, 3, 4, 7, and 2. Now we'll move on to the next slide, starting with the first example for the binary operators overloading. So here is the first example for the binary operators overloading plus. In the left side is the code for C++, and the right side we have the code for Python. Let's start with C++ first. In the main function, first we have defined 2 points here, 5, 7 and 7, 8. This 5 and 7 will be assigned to x and y variables, member variables of the class respectively. Now what we're trying to do here is we're trying to overload the plus operator, and when we say p plus q, we're assigning it to answer. This plus will be acting as function called by this p. So the q here is directly passed to the point other that we have defined in the function here. And in this function, we are defining a point temp. The x and y values that we'll be assigning to it will be in this way as this arrow x plus other dot x. This means that in this arrow x, this will be the x value of the variable, the point variable p, and the other dot x is the x value of the point object q. So we add both of the x coordinates and assign it to temp dot x. Similarly, for the case of y, we do this arrow y plus other dot y, and we add the values of p and y variables for y and assign it to temp dot y. And then we return this temp variable. And so this particular temp will be assigned to the point answer. Now, when we try to display this particular answer object, we get the value as 12 as 15, which is same as adding the x coordinates of p and q, which is 5 plus 7, and adding the y coordinates of p and q, which is 7 and 8, resulting into 12, 11, 15. Now, going on to the Python, we see we have defined a class as point2, which is inheriting a point. This is done for the case so that we can demonstrate in this particular small slide. Now, and what we've done in this is, again, we defined 2 point objects, p and q, as passing at 5, 7 and 7, 8, and saying answer equals p plus q. Now, for this, we have the magic function known as underscore underscore add underscore underscore. And in this, we have passed another self, the self-referencing this pointer, this variable, the p, and the other we have the q. So we define the same as in the case of C++, we defined a temp point here, and just adding the x and y coordinates and assigning it to temp.x and temp.y. We return this temp variable, which is a point class, and this will be assigned to the answer. And when we try to print this particular answer as answer.x and answer.y, we get the answer as 12 and 15, just in the same case of C++ as we got it. Now we can move on to the next binary operator, which will be covered on by the next one.
The next example in binary operator is a left shift operator. In this, we are going to shift x and y variables of an object by particular number of bits, that is a in this function. Here we have created an object p of class point with its variable as 2 and 4, and we are left shifting it by two bits, and then displaying it. It will give as an output 8 and 16. Where 8 is the left shift of left shift of 2 by 2 bits, and 16 is the left shift of 4 by 2 bits. As in the case of Python, we are invoking the function underscore underscore L shift underscore underscore. Here we are creating a temporary object point2 with its variable 0, 0, and assigning its x variable to the x variable, which is shifted by a number of bits, and same as y, we are assigning the temp.y to self.y, shifted it by a number of bits, and returning this temporary variable. Then we have created a point2 object with its variable x and y as 2 and 4, and then left shifting it by number of bits 2. Then after printing those values, we will get 8 and 16, as in the case of C++. Let's move to the next slide.
Nisha, why did you choose to return the object? Because in the left hand side you just return void. In the right also you could just return void, no? Why do you create a new object? You could just sub.x you could shift by a, sub.y you could shift by a, and that's it. You just say sub.x equal to sub.x shifted by a.
Yes, sir. This can be done as in the case of C++.
So why did you decide to do this way? Just all
No,
right.
it can be done both the cases actually.
Yes,
we just
sir.
like prefer to do it like that way.
All right. Continue.
So coming to unary operators order, first of all, what is a unary operator? It is an operator that acts on a single operand to produce a new value. And types of unary operators are increment plus plus, decrement minus minus, and logic or not, and negate, etc. And coming to overloading, it is an overloading of an operator operating on a single operand. So in a unary operator function, no argument should be passed. So let us consider to overload negate unary operator. So we define the function operator minus of user defined data type. So it will return a point with negate x coordinate and negate y coordinate. So coming to the main function, so we call p equal to negate of p. It just invokes the it just calls the operator minus
I
function.
have a doubt about your this example also. You are
Yes, sir.
already negating x equal to negation x and y is equal to negation y, and then you could just return this.
Which one? Sir, in the main class object, we define point in that way. In the main class object.
Yeah, but you don't need to return anything. Even if you want to return something, you could return this object itself.
Yes, sir. We can do in
Get a
that
new
way.
object.
But in the main class function, we define that's.
Yeah, I understand. My because thing is that you are already changing the object
Yes,
itself.
sir. Yes, sir. X equal to negative of x. Yes.
Yeah. So
Yeah.
why do you need to create a new object and return it? You can just return this object itself.
So coming to in the Python, like as Nitish told, if place operator in like this invokes underscore underscore add, here negate operator invokes underscore underscore negate underscore underscore. So it will return negate of those x coordinate and negate of y coordinate. So it's the same thing. Move into the next slide.
Yeah, so now I'll talk about the relational operators, less than. So to overload the less than operator, we first use the operator keyword followed by the less than symbol. And here we return a bool variable, hence return type is a bool. And this function was defined in the class point. So,
What is this? What is this? One second. What is this point and p? What does that mean?
So point and p means that the p will be a reference of that type of the point class type.
Okay, all right. All right. So you see that how we have used reference variables here. Yeah. So this is one of the main uses of reference variables. That if you want to affect some changes on the past element, you can capture it in a reference variable, and then it becomes a reference to the past argument. All right, continue.
Yes, sir. So to compare 2 points, what we do is so if the x of the point which is calling this less than operator is lesser than the x of the point to which this operator has been passed, if that is so, then we return true. If it is not, then if we check if the x is equal to p dot x, and if y is less than p dot y, then we return true, and in all other cases we return false. So now below in the main function, we have defined 3 objects of class point P1, P2, and P3 with 5, 4, 4, 4, and 5, 5. So now when we call the less than operator with P1, so when we do this P1 less than P2, what it does is it will compare the point P1 with P2, and P2 will be the past point to P, the point and ampersand P. So now since the point P1 is not lesser than P2, it will output 0 or false. And since P1 is lesser than P3, it will output 1. Now on the right hand side, we will move on to the Python operator overloading for the less than operator. So in Python, it is again simple because we have this function underscore lt underscore.
Yeah, so these functions are called dunder functions, double underscore. So you take the d of the double and underscore from you underscore you take under. So you call it dunder lt.
Okay, sir. Dunder lt.
Dunder functions. Yeah.
Yes, sir.
These are also called the magic functions, right?
Pardon?
Magic functions.
Yeah, they are also called magic functions, but they are called double underscore because all the functions for operator overloading starts with double underscore and ends with double underscore. It's a C tradition. So in Linux kernel also you can see a lot of double underscore, because typically in Linux kernel, whenever you write helper functions, yeah, you might have one function for the operating system, the kernel, and then for particular implementations, you might need several helper functions for each of the particular processor architecture, for instance. So then the typical custom there is that you will have a function definition, and for each of the particular processor architecture, you'll have a double underscore function. Okay, system functions. That is, it's just that is where the double underscore started in C, but Python uses double underscore for these kind of special functions. They are called dunder. Yeah, continue.
Yes, yes, sir. So the logic again to compare 2 points in Python is also the same. So below we again define three instances, I mean three objects of the class point2, and point2 has been inherited. So the class point2 has inherited the class point. So then again we define three objects p1, p2, and p3 with 5, 4, 4, 4, and 5, 5. And then if you print p1 less than p2, it will return false, and p1 less than p3 will return true. Yeah. So we'll move on to the next slide now.
In the second example for relational operators, we try to overload the not equals to operator. Looking at the C++ code on the left side, the return type of this function is, this function is again Boolean, and we use the operator not equals to method to overwrite it.
Yeah, but this is the same as less than. I think.
Yes, sir.
Yeah, I mean, there is nothing new here.
Yeah. So.
Okay, continue.
Basically, yeah, the logic for this function is we first compare the x coordinates. If they are unequal, we return true. Else we compare the y coordinates. And if we find that both the coordinates are equal, we return false. Else we return true. And in the main function, we can see that in the first example, P1 is not equals to P2 will return false since P1 and P2 have same coordinates, while the second example will return true since P1 and P3 are unequal. Similarly, in the case of Python, we use the underscore negate underscore render function to overload the not equals operator, and we can see the similar output in this case also. Moving on to the next slide.
Yeah, so now we look at the input output operators overloading. In the case of Python, for the input operator overloading, we do not have any specific function, but in the case of C++, we do have. So for the output operators overloading, first we'll have to look at the output operators. So for Python, I think there's some disturbance. Okay, so for the output operators overloading, we have this inbuilt class OStream in C++. And so for that, what we do is we define this operator function with the less than symbol. So this less than symbol is used for the output operation. And this ampersand operator is written because what we're doing is we are returning a reference of the class OStream. So the first parameter of the function is OStream and output, and second is point and p.
Excuse me, Nidish, 1 second. Vipul, can you please mute your mic? It's his voice is not audible. Nidish's voice.
Okay. So from where did you guys miss?
Yeah. Can you please explain the slide from the start again? It was not audible to me at least.
Yeah. Okay. So for the input output operators, what we have is, for in the case of Python, we do not have any specific function to overload the input operator, but in C++ we do have. But here we'll only have to look at the output operators overloading. So in the case of C++, on the left hand side, we have this built-in class OStream in C++. So what we do is we define this operator keyword along with this less than sign. So this sign is used to denote the output operation. And then we have these parameters OStream and output and point and p. So we are defining this AND operator less than because we will be returning the reference of the type OStream. So in the function, what we do is we so output less than x less than p dot x y p dot y. So what we're doing is we're just inserting this stream in output, and then we're returning this variable this reference to that output. So in the main function, we have this object P with initialized with 3,4 as x, y. And then when we use this C out, so this C out is a built-in object of the class OStream. So when we use C out along with less than, so now this will now this less than will be overloaded with the definition as we have defined. So now if we do C out less than P, it will output x colon 3 and a space y colon 4. Now, on the right hand side, in the case of Python, what we do is we have this dunder str function. So now we'll just return this string x format. I mean x self.x comma y self.y, and below what we do is we define this point to object 3,4, and again if we print it, it will be overloaded and the output will be x colon 3 and y colon 4. Yeah. So now we'll move on to the next slide.
Okay, so now we try to overload the assignment operator, and here we overload the plus equals to function. An important point here is to know that we cannot overload the equals to.
The previous one second. This previous is non-trivial.
Yes. So which one?
In the sense that you have two different meanings of less than.
Right, sir. Right, sir.
Yeah. Did anybody catch that?
So yes, sir. So in C++, this less than when we use it for left shifting, it is overloaded for the functionality of left shifting, and when we use it along with C out less than, it is overloaded for the output operation.
Yeah, that is not just what I meant. This is an example. See, C out less than already has a meaning. Okay, C out less than with a, so your the line in your function output less than x, I mean string x colon less than p dot x less than, yeah, that line, the less than has multiple definitions. One definition, so here you are defining a new definition of less than which uses the old definition of less than.
Yes.
You getting what I'm saying?
Mm-hmm.
So C out less than P. Now when I write C out less than P, there is no definition of less than with that signature or stream and output. I mean, there is no definition of C out with a point object. Okay, but the compiler will search for a particular suitable definition, and then it will find this definition of the one which we have just defined. Now within that, you go into that and you see that there is a new line which is output less than x colon and so on. Now for that, there is already an existing definition which is defined in std out, where you know how to put C out and a string. Yeah, are you getting what I'm saying?
Yes, sir.
Siddharth, did you understand what I'm saying?
Sir, I didn't fully understand it.
Pardon?
I didn't fully understand it.
Nitish, so this, can you explain what is this less than which uses in? So you are it seems like you are defining the operator less than, but within that definition you are using the operator less than. Yeah.
Yes, sir. Yes, sir. So,
how does that
work? Yeah. So in C++, we have this internal definition when we are inserting something in a variable. So for example, if we use this less than along with C out, then what we do is the value which we have on the right hand side, it is inserted in the C out. But in the case of this output variable, what we're doing is, so when the compiler will come at this line, it will see that for this output less than, it already has a definition for this less than operator. So it will input this string and the p.x variable inside the output, and it will just return it.
Exactly. So even though you are defining a new definition for less than, within that definition you are using an old definition for less than, because according to the old definition, you know how to output a string and an integer, etc., to an output stream, to the output stream C out. Now you are using that definition of outputting of adding a string and an integer variable, etc. to a stream to define a new definition for less than less than. Okay, so these are two examples of operator overloading, where within one definition of the function, you are using another definition of the same function. Is it clear now what I'm saying?
Yes, sir, it's clear.
All right, continue.
Okay, so here we try to overload the plus equals to function. I was saying that there's an important point here to know that we cannot overload the equals to operator in Python since there is no special function defined for it. So in this example, we overload the plus equals to operator and make it behave like the assignment operator or the equals to operator. In the C++ code on the left side, we accept as input the reference to the point whose assignments are to be used using point ampersand p and assign the x and y coordinates in the subsequent lines. In the main function, we can see that we have defined a point p1 5,4 and another point p2. This the coordinates of point p1 are assigned to p2 using the plus equals to function we have overloaded. And when we use the p2.display method, we can see that the coordinates of p2 are changed. In the case of Python code on the right side, we inherit the point class in the point2 class as we did before. We overload the plus equals to operator using the dunder function iadd and assign the coordinates to the point and return the same. Below the function, we can see that point p1 having coordinates 5,4. These coordinates are assigned to the newly created point p2 using the newly overloaded operator, and we can print to see the output. Moving on to the next slide.
So now we'll talk about the subscripting operator overloading. The subscripting operator, as we know, it is used to index an array and retrieve or set the value. At the left side, we have the definition for C++. First, let's go to the main function. We define a point P, and now we're trying to see out a point P1. The thing is here, we had defined a array X points with 4 values as 3, 4, 7, and 2. Now, what we're trying to achieve here is that array by default is 0 index. We want to make it a 1 index array. So we'll try to achieve that. So when we try to say C out P1, what happens is it is printing 3. This means that was the 0 index of X points. So as we see in the function defined in the subscripting operator overloading, we have passed an index here. In this case, it will be 1. So we first check that if the index is greater than the size of that particular array, which was 4. So now 1 is not greater than 4. So we'll return the come out of this block and return X points index minus 1. Index here is 1 and 1 minus 1 comes as 0. So we return X point 0. So in this way, what we have achieved is we have made an array which was supposed to be 0 index, and now we are addressing it as 1 index array. In next case, we see C out P5. This will be actually interpreted as an X points 4. But this X point 4 is also out as 4 indexes out of bounds for the X points. So in this case, we will be getting out of bounds for this particular value. That was for retrieving the value. Now for assigning the value, it goes the same. When we say P2 equals 9, the index that will be passed to this particular function, it will be 2. This will be referring to X points 1, it is 2 minus 1 as index minus 1, and it will return X points 1. So by referring here P2, we are actually changing the value of X points 1. So in this case, when we say P2 equals 9, the 9 will be assigned to P2, which is same as X points 1. That was the case for C++. Now, let's go to the Python. We have defined a class point2 inheriting the point. In this also, we had defined the X points array, which consisted of 3, 4, 7, and 2. In this, we have the dunder functions, get item and set item. First, we define the point2 object, and we try to print P1. This is again, this will be for this particular thing, the function get item will be called. First, we try to see if the index is greater than this particular X points list. And if it is so, it will return index out of bounds. Otherwise, if it is not so, then it will return self.x points index minus 1. It is same. We get an value of a list which is 0 indexed by giving a value as supposing it as the 1 index. And when we say print P5, this 5 will be out of bounds for this particular thing. And it will be referring to x.4, which is again out of bounds there. So we'll return index out of bounds here. And when we say P2 equals 9 here, for this particular assignment, the set item dunder function will be called. We have the index here as 2, which is passed here, and 9 is the value here. And we try to again check if the index is greater than this x points list size. And if it is so, index out of bounds is written. And if it is not so, we assign this particular value to x points index minus 1, which will be actually x points 1 equal to val. So in this case, we have achieved what is supposed to be 0 index and converting it to the 1 index. And this actually helps in some cases when we want to refer in the case of when there is indexes is in the case of 1 index is there and rather than 0 index. This was the overall operator overloading from our side. And here we conclude our complete presentation. Thank you.
All right, thank you. Can you upload these slides to Piazza?
Okay, sure, sir.
Yeah.
Actually, I have a doubt in this in the T out example. So can you, yeah, here why have you used constant point instead of and like just point in the C++ case in the arguments?
The constant point and P just means that you are not changing that P at all. That's all it means. Yeah. Constant can be put in many places. It can be put there. It can be put after the function and so on. Constant typically means that in this case it means that you are getting into a reference variable and you're not changing it. That's all it means. So in case you use it within that function, if you tamper with it, then the compiler will complain.
Okay, sir. So basically, that constant could have been avoided, and also that ampersand symbol is not required in this particular example, right?
The ampersand thing is not. If you don't have ampersand, then you won't be able to address it at p.x. One second, let me just think. Yeah, it's if you don't put it as ampersand also, yeah, even without ampersand it will work.
Okay, sir.
Okay, so I think that is the reason they put constant, that you are getting reference but you're not changing it. So you could also put point P, no problem. Okay.
Yes, sir. Thank you, sir.
All right, it was good, but yeah, I mean, yeah. All right, it was nice talks. So day after tomorrow, whose turn it is? Let me see. Virtual function abstract classes inheritance in C++. Okay, then thank you, everybody.
Thank you, sir. And
thank you, sir.
Do we need to upload the slides to Piazza?
Yeah, please.
Every club. Okay.
Yeah. Thank you.